Hello and welcome. AI infrastructure engineers are in high demand, and in this video, I'm going to share you a complete roadmap that you can follow to become a top-notch AI infrastructure engineer. So, without further ado, let's get started. So, first of all, here's the agenda. I'm going to talk about what is AI infrastructure role all about, right? And then, what's the difference between AI engineer versus AI infrastructure engineer? Because there's a lot of confusion in the market between these two. So, I'll throw a light on that, and then I'm going to talk about how to become an AI infra engineer, what exactly it takes, or what skills you need to master to become an AI infrastructure engineer. And then I'll also give you the learning resources that are available for you to become an AI infrastructure engineer and start off your AI infrastructure engineer journey. All right. So, first of all, what is AI infra engineer all about? An AI infrastructure engineer is someone who designs, builds, and maintains the high performance computing systems, right? GPU clusters and orchestration platforms that are required to train and run large scale artificial intelligence models. So you basically the AI engineer basically builds that infrastructure that is needed to run AI, right? And therefore they bridge the gap between machine learning models and physical hardware, ensuring reliability, low latency, and cost efficiency. Right, that's what this role is all about. And it's a very powerful and very impactful role. Okay, so what is the difference between AI engineer and AI infrastructure engineer? Let me address the elephant in the room. Okay, so AI engineer is someone who builds the intelligence in a nutshell. So they take the models that are built by AI researchers and try to apply the intelligence that's there in the models to solve business problems. Okay, whereas AI infrastructure engineer ensure that AI runs successfully on the infrastructure. So they build the infrastructure that powers AI. That's the difference. All right. Let's take a look at the skill set that's needed for AI engineer. So AI engineer needs to know RAG, that is retrieval augment generation. They need to know about AI agents, how to build AI agents, how to run them, how to have guardrails around AI agents. They should be able to do fine tuning of the models, right? To apply those LLMs to solve business problems. Then model evaluation. Then they should be well versed with programming languages like Python and APIs and prompt engineering, so on and so forth. So it's all on the software side of things, right? So that's what an AI engineer needs to know and needs to master. Whereas AI infrastructure engineer needs to really know the infrastructure on which the AI runs. Like they need to know about GPU architecture, Kubernetes that does the orchestration of your containers, and then run AI, and then networking, observability, inference engines, and then networking, and again NVLink. And InfiniBand, RDMA, and the storage as well. So they need to know the infrastructure side of things, whereas AI engineer needs to know the software side of things, or programming side of things. All right. So that's the difference between AI engineer versus AI infrastructure engineer. Now, moving on. Now, what does it really take for someone to become an AI infrastructure engineer? Let's take a look at that. So, for an AI engineer, he or she needs to master these seven pillars. The first one is GPU architecture. So they should know and they should understand the hardware, right? Whatever the various GPU families and how do GPUs work, the underlying technology, so on and so forth. And then they need to also know about AI compute and security, because in order for you to leverage that hardware, you need to build containers on top of it. You need to leverage them using Kubernetes, so on and so forth, right? And then they need to know about AI workload platforms like Run AI, so that you can really orchestrate the AI really well on these GPU hardware, leveraging Kubernetes and Run AI platforms. And then you need to connect multiple GPUs together. For therefore, you need to know about networking. How do you connect multiple GPUs? How do you connect multiple racks of GPUs? What are the various GPU or networking technologies out there? And then they also need to feed the data to the GPU, because in order for you to run or train the model, you need to have data. For that, you need to know about how do you feed the data. What are the data pipelines, and how do you develop those data pipelines? What are the technologies that allow you to develop those pipelines or transfer the data really quick to the models? And then once you build all your infra, you need to really serve your customers. For that, you need to know about Inference Stack, like TensorRT, Triton, vLLM, so on and so forth. So they should be well versed with inference engines as well. And then last but not the least, they also need to know about observability and operation as well, because you need to continuously keep the lights on. You need to keep your infrastructure running. Therefore, you need to know about observability and operations as well. Right. So moving on now, again, moving on. So Now let's dive deep into each pillar and try to understand a bit more about them. So when it comes to GPU architecture, what exactly do you need to know? You need to know about GPUs, like Nvidia GPU families like Pascal, Volta, Ampere, Hopper, Blackwell. What are these families, and how are the GPUs different from each of the families? How the innovation has evolved, right? You need to know about that, right? And then you need to know about CUDA. CUDA is a very important programming language from Nvidia, so that really allows you to do a lot of programming with your hardware. So you need to know about CUDA as well. You need to know about memory, how the memory works, the high bandwidth memory, and then LVL to cache, so on and so forth. And then you also need to know about tensor cores, right? And then NVLink and NVSwitch that allows you to connect multiple GPUs together. So these are the things that you need to know. These are the things that you need to master, right? And then moving on from GPU to AI compute and scheduling. So when it comes to AI compute, now you have mastered GPU architecture. Now you need to understand how exactly you will leverage that hardware. That's when Kubernetes come in. So you need to be well versed with Kubernetes cluster architecture, right? How exactly Kubernetes work, name system and isolation, RPAC security, and so on and so forth. Now, in order for you to effectively uh, orchestrate your uh, containers, you also need to know about GPU operator, and you need to also know about MIG, that is multi-instance GPU, right? What exactly is this, and how does it work? You need to have the hands-on experience as well, and then you need to know about scheduling and resource management as well. Now, moving on, once you learn this, you need to master AI workload platforms like Run AI. So Run AI is something that allows you to, you know, so Run AI is a software platform designed to orchestrate, virtualize, and manage GPUs and compute resources for artificial intelligence. So it works hand in hand with your Kubernetes. So you need to know about Kubernetes and Run AI as well. Whereas Run AI is a modern one and Slurm is an slightly outdated one. So a lot of companies are now moving towards Run AI. So you need to know about Run AI, and then containerization, as I said before, and then multi-node training. How do you really train multiple nodes together? How do you distributed computing is what you need to master as well. So you need to know about AI workloads platform, whereas wherein Run AI is very, very important. Now, moving on, once you master that, you need to move on and understand about networking. Like there are multiple networking technologies like InfiniBand, RoCE, RDMA, NVIDIA networking. So you need to know about how exactly this works. What is the role RDMA plays, right? RDMA is something that's leveraged by both InfiniBand and RoCE. So you need to master that as well. And then inference stack, this is very, very important, right? You need to know about various inference engines. You now you have developed your models, you have built an infrastructure. Now is the time to serve your customers. And how do you serve them? How do you inference your model? For that, that's when this TensorRT-LLM, Triton inference server, vLLM, and these sort of things come in. Now you might be wondering, what is the difference between TensorRT and TensorRT-LLM? Now, first of all, let me say this: these four, like the TensorRT, LLM, Triton Inference Server, and vLLM, these four systems are high performance AI survey tools, but they work at different levels, right? They work at different levels. TensorRT accelerates general deep learning models, whereas TensorRT LLM is specialized for large language models, right? This is for, remember this is for general deep learning, whereas TensorRT LLM, as the name says, this is specialized for LLMs, and vLLM provides flexible open source LLM serving where page attention. So it really helps you serve that those LLMs. And then Triton acts as an overarching enterprise orchestration servers that can host all of them. So this is sort of a server that can host all of these things. Right, that's the difference. Now, moving on. Now, you need to know about, you need to, as I said, you need to feed the GPUs. That's when data infrastructure for AI workloads come in. So you need to know about NVMe, how exactly it is, what exactly it works. So that you know about object storage, right, and then reliability and operations as well. And then you need to know about the architecture and design of NVMe and parallel file systems, so on and so forth. All right. So these are things that you need to master to really become a top-notch AI infrastructure engineer. Now, how do you master them? In order to master, there are certain courses that have been created. I myself have created a full course on fundamentals of NVIDIA's AI infrastructure. I'll link the link of that in the comments. And besides that, I'll also share you learning resources from other providers like NVIDIA and others, so you can go ahead and start off your learning journey. So watch out for that in the comments, right? So in summary, you need to master these 7 pillars, and out of these seven, GPU architecture, I have got a course, and then a networking, how really the networking works, the inference, and a bit of a workload platforms as well. So I've created a course regarding all of these. I'll link to it in the description, in the comments, and I'll link the other courses as well, so you can go ahead and master. Hope this was helpful. Hope this will help you become a top-notch AI software engineer. Thank you so much. See you in the next video.